All right, so some review stuff. First one, let's solve a complex problem. So 6 times 2 plus 3i, negative 5, 9 minus I. So this problem is a mixture of both subtraction and multiplication. So first thing you want to do is undo your parentheses. So I'm going to start by multiplying in. When you multiply it in, remember I kind of just acts like a variable. So in this next one, you multiply in, and then a negative times a negative will make it a positive. You've now undone your parentheses, so now you're just really combining like terms. So 12 and minus 45. Your real portion is a negative 33. The imaginary portion, 18 plus the 5, 23i. When you're just adding and subtracting, your i's will not change. So that's why an 18i with a 5i just stays 23i. The only times your i's change is when you are multiplying an I with an I, not when you're adding or subtracting. A multiplication problem. This is to serve as a reminder. When you see a parenthesis squared, it does not mean 25 plus 4i squared. You don't just square both parts. This means you have two of the same parentheses. Once you rewrite it as two of the same parentheses, you go ahead and you FOIL it out. So negative 5 and negative 5, negative 5 and 2i, 2i and negative 5, 2i and 2i. So the 2's make a 4, I and I make I squared. When you guys are going through your multiplying, make sure you follow the numbers. Whenever we get an I squared, what is I squared the same as? It's negative 1. So this is going to make a minus 4, because really it's 4 times negative 1, which is negative 4. This negative 4 can now be combined with the other real portion, so 25 minus 4. Your i's, are they going to cancel here? No, they're both negative. So since they're both negative, you just put them together. So negative 10 minus another 10 gives us negative 20i. So when you are multiplying, just make sure you're careful about this I squared that you're going to create, and then the middles, be careful if it's going to cancel or not. Last I one we're going to do is a division problem. So with both of the things we've been working with, the i's and the fractions, division, we're just going to use a trick and use multiplication to help us get this answer. So in order to multiply complex numbers, what do we have to multiply? By the conjugate of the bottom. So we look at our denominator, we have 1 plus 9i. So I'm going to take both top and bottom times 1 minus 9i. Again, you look at the denominator, conjugate just means whatever the I portion is, you take it to the other sign. Up top, what we're doing is 8 times 1 minus 9i. So because it's a single 8, you're going to multiply it, 8 and a negative 9, 72? Yeah, 72. I. So that is our new top. When do we multiply the bottom? We have 1 plus 9i, 1 minus 9i. Full foiling here, so 1 times 1, 1 times negative 9i, 9i times 1, 9i times negative 9i. So negative, and then I squared. Whenever we get this I squared, we're going to cross it off, and that I squared is going to change our sign. This is now a plus 81. So 1 plus 81 is 82. When you put the imaginary portions together, will these cancel? These are the ones that are going to cancel. You have one positive, one negative. So after you multiply by the conjugate, we take our new top over our new bottom, and technically we're done dividing here. But in terms of complex numbers, we always want to split it into two fractions because we want to show the real portion and the imaginary portion. They are going to have the same denominator, so it's 8 over 82. Since this is a minus sign, this is a minus sign, 72 over 82. The reason you split it is this is now something that you can reduce. So looking at the 8 over 82, I'm going to first check to see if 82 can be divisible by 8. It's not. So then you're like, okay, well, what else divides 8? And you're like, well, 4 does. 4 doesn't go into 82. But we can divide both of these by 2. So to reduce this fraction, divide by 2, divide by 2. Nothing will go into 4n41, so we're done right there. You do the same thing with the 72. So 72, is that divisible by 2? Yeah. If we can start out and divide both of these by 2 again, 72 divided by 2, 82 divided by 2. Nothing goes into 36 and 41, so you just know you're done right there. So the splitting is really just acknowledging you have your real portion and you have your imaginary portion, and you can reduce your fractions to kind of finish it out. So the I stuff is going to be half of your quiz. The other half is going to be doing all the fraction stuff we've been doing. So first one, we are going to do a simplifying one. Simplifying a rational just means you have one fraction. So we don't have two fractions that we're multiplying or dividing. Instead, we just have one fraction. When you guys look at this one fraction, sorry, I wrote this wrong. That should be a 2 right there. As soon as you see plus minus signs, what do you have to do first? We're gonna have to factor this. So up top, greatest common factor, we can take out a 3, we can take out an x. That'll leave us with 5x plus 3. On the bottom, what's our greatest common factor gonna be? Again, it's gonna be a 3 and an x. That'll leave us with 3x minus 10. Once you have it factored, anything on top can reduce with anything on the bottom as long as they are the exact same. So they have a 3 on top and bottom. They have an x on top and bottom. That's the only thing that can cancel. This other stuff is stuck. So the 5x plus 3 is all one chunk. 3x minus 10 is all one chunk. So those x's can't cancel. So final answer, 5x plus 3 over 3x minus 10. So simplifying, just make sure as soon as you see plus minus signs, you're gonna want to factor and then start reducing. A multiplication problem. So n minus 5 over 50n squared minus 50n cubed times 50n cubed minus 50n squared all over 6n. So these ones, again, you see plus minus signs, so we want to make sure we factor things. When you multiply fractions, how do you multiply fractions? You're going to go straight across. So we really just think of this as one big problem. Starting in the top left, nothing is going to factor n minus 5 anymore, so that one stays. With your guys' factoring, there's a couple different ways you could do this. Most of the time you're going to look for a greatest common factor first. So when we look on the bottom left, I can take out a 50, I can take out an n squared. That'll leave us with 50 divided by 50 is a 1. The n squared's gone. 50 divided by 50 is a 1. We have 1 n left over. Up top, top right, again, look for your greatest common factor. What can we take out? We can take out a 50n squared. So that'll leave us with 1n minus 50 divided by 50 is 1. And then on the bottom, 6n can't be broken down. Once you have it all factored, anything on top can reduce with anything on the bottom as long as they are the same. So right away, they both have a 50, so those are gone. They both have an n squared, so those are gone. And then something that feels like it should reduce, the 1 minus n and the n minus 1. So this is the trick. As long as it is subtraction, if they're backwards of each other, what will these ones leave behind? They'll leave behind a negative 1. So they do cancel, but because this technically can have a GCF of negative 1 taken out, it's going to leave that negative 1 behind. Nothing else is going to be able to cancel. This n is attached to the 5 on top. We don't have that on the bottom. So up top, we have a negative 1 and then an n minus 5 left over. On the bottom, we just have 6n. So when you guys are multiplying, just make sure it's factored. Anything on top reduces with anything on the bottom. All right, last one, let's do a division problem. So dividing, if we had 15x squared y to the third over 2xy divided by 25x x y to the 6th over 10x. When you divide fractions, what is the trick for dividing? So the trick for dividing would be this second fraction, you flip it, and when you flip it, it is now a multiplication problem. So the first one does not change. The second one flips. Once you flip it, it turns to multiplying. So we just rewrite our division problem as a multiplication problem. The trick for fractions is you flip the second. Once you have this flipped, anything on top goes with anything on the bottom because we're multiplying. So think of this as one big fraction. Without any plus minus signs, there is no reducing, or there's no factoring. We can kind of just jump into it. Number-wise, there's lots of different ways to do this, but right away, like the 15 and the 25 jump out to me. They're both divisible by 5, so now that's a 3, that's a 5. The 2 and the 10 jump out to me. 2 goes into 10 5 times. And then look at this, we have a 5 on top, we have a 5 on the bottom, so those 5s can cancel out. Variable, I have a single x and a single x, so I'm going to cancel those out. And at any time, just take a second and kind of rewrite what you have. So we still have a 3 up top, we have an x squared, we have a y to the 3rd. On the bottom, we don't have any number, we have a single x, and then when we put those y's together, we're going to have 7. So rewriting what I have, just making it easier to track what's going on. To finish it out, again, my 3 is stuck. If we look at our x's, we subtract our exponents, we're gonna have 1 left over on the top because there's more on top. How many y's will we have left over? 7 minus 3 is 4. Where will they be? On the bottom. Thank you for watching this. Make sure you keep your paper, and I will see you for the quiz. Bye.